Hello everybody, I'm here with an example of acceleration in NT coordinate system, normal tangential coordinate system, related to curvilinear motion, which is a motion where the particle travels along a curved path. So here we have, you're told that car A has a speed of 25 meters per second at point A, and then it's uniformly decelerating from point A to point C, where the velocity decreases to 15 meters per second at point C along this curved path. And the radius of curvature, as you could see, at point B is 300 meters. So uniform deceleration means constant acceleration, and that would be actually constant tangential acceleration. So remember, rate of change of this velocity is v dot, or dv dt is the tangential component of acceleration. So the question here is, we want to find the magnitude of acceleration of the car at point B, right here. Okay? So, you see from the information given related to velocity of the car at A and velocity at C, and the fact that tangential acceleration or deceleration is constant in this case, we can go ahead and actually use constant acceleration. Actually, you guys remember that A sub t, which is dv dt, is also v dv ds, right? And then this, if we have constant A sub t, eventually becomes v squared minus v0 squared equal to a s minus s0. If you actually put the subscript, so your initial is point A actually, and your final is point C, so you could use this, right? So if you go ahead and plug in, and this, by the way, would be A sub t now here. So if you plug in the numbers that you have, so velocity of C is 15, velocity of A is 25, right? 280, and what is the total distance traveled from A to C? And I would S sub C minus S sub A. That is actually 300 meters, as you could see. So you could put that right there, and you can go ahead and solve for A sub T. Obviously, this is going to be negative, which makes sense because it's decelerating. So it becomes 0.0667 meters per second squared. And remember, this is a constant. So the question is, how do we find acceleration at B, magnitude of acceleration? Remember, magnitude of acceleration at B or at any point is actually the combination of the tangential component plus normal component, in this case, square root of A sub t squared plus A sub n squared. Well, from A to C, we know that tangential acceleration is constant. So we already have the tangential acceleration at point B. The question is, what is normal acceleration? Well, normal acceleration, as you guys know, is v squared over rho. So what is velocity of B? If I have that, then I just divide it by radius of curvature, which is 300 meters. So how do we go about finding velocity of B? Well, why don't we just use the same equation, but this time we say, okay, velocity of B squared minus velocity of A squared. In other words, use A as the initial velocity, equal to AT S sub B minus S sub A. So in this case, velocity of B is the unknown, and velocity of A, again, we know it's 25. Remember, A sub t is minus 0.667, right? Decelerating. And S sub B minus S sub A is what? It's only 250 meters. So if we go ahead and solve for velocity of B, it becomes 17.08 meters per second. Now you can take this and plug it right in here, right? So why don't we do that, right? 17.08 squared divided by radius of curvature, which is 300 meters, right? So that comes out to be about 0.9722 meters per second squared. So if I could show you graphically what's going on here, see, this is the tangential axis at this instant again. This is the tangential axis, right? Tangent to the path. And this is the normal axis, sorry for the mess. And we already have a tangential deceleration, which is actually acting in the opposite direction of, so that's your a sub t, which is the 0.667, right? And your normal acceleration is a little bit larger, about this much, 0.9722. So the total or magnitude of acceleration at point B actually becomes the resultant of the two. So that would be acceleration of B, which can be determined here easily by using the equation that I showed you here, right? So negative 0.67 squared plus the 0.9722, that's the centripetal acceleration or normal acceleration. So acceleration of B, the magnitude comes out to be about 1.18 roughly meters per second square. So this is the 1.18 meters per second square. Okay, so this was another example, another simple example of how, in order to find the magnitude of acceleration when a particle travels along a curved path, in this case the car going from A to C, what do we need? One coordinate system obviously is nt, and we can find tangential acceleration and normal acceleration, and then eventually find the resultant of the two as shown in this picture. Again, as always, thank you for watching and listening, and if you like the video, just try to subscribe to my channel. Thank you.